Welcome to the unit on quadratics. In this unit, we will be looking at some review exercises. The objectives for this session are to review previous topics through exercises, namely, solve linear and quadratic equations, factorize equations, and sketch graphs of equalities and inequalities and label important points on the graph. Pause the video and have a go at these review exercises. When you are ready to view the solutions, press play. So let's take a look at review exercise 1a. Solve 8x plus 2 equals 2x minus 1. We begin by subtracting 2x from both sides so that all the x's are transferred to one side, as shown. Now let's tidy up. 8x minus 2x is 6x. 2 is as it is. The 2x's on the right-hand side now cancel. And minus 1 stays as it is, giving us 6x plus 2 equals minus 1. Now we need to bring the constants to the other side. So subtract 2 from both sides to get rid of the constant on the left-hand side. Now let's tidy up. The 2's cancel. 6x stays as it is. Minus 1 minus 2 is minus 3. Now divide through by 6. Giving us x equals minus a half. And now for exercise 1b. Let's expand the brackets first. 3 times x, 3 times minus 1, 4 times x, and 4 times minus 2. Now bring the x's to one side by subtracting 3x from both sides. And now tidy up. The 3x's cancel and the minus 3 stays as it is. 4x minus 3x is x, and minus 8 is as it is. Now rearrange so that the x minus 8 is on the left-hand side and the minus 3 is on the right-hand side. This allows us to give an equation in the form x equals something. In order to have the constants on one side and the x's on the other, add 8. Adding the 8 allows us to cancel the minus 8 and the plus 8 on the left-hand side. So we're left with x equals 5. As shown. Now for exercise 1c, 2x squared equals 32. So we divide through by 2 in order to get rid of the 2 on the left-hand side. The 2's cancel. And finally we can square root both sides to give us x equals plus or minus square root of 16. Giving us x equals plus or minus 4. And now for exercise 1D. Square root both sides to give x minus 4 on the left-hand side and plus or minus root 16 on the other. This gives x minus 4 equals plus 4 or x minus 4 equals minus 4. Therefore, rearranging gives x equals 8 or x equals 0. And now for exercise 2a, factorize the quadratic shown. Notice that 2x plus 5x equals 7x and 2 times 5 equals 10. So we can split up the quadratic as x squared plus 2x plus 5x plus 10. This allows us to take x plus 2 out as a common factor for the first two terms and for the last two terms. So as you can see, the two lines are equal. We have x squared, 2x, 5x, and 10. And now we can take out x plus 2 as a common factor for both terms here, and x plus 5 is the other factor. So our quadratic has been factorized. Now for exercise 2b, factorize x squared minus 3x minus 10. We will factorize using the technique used in part A. So notice minus 5x plus 2x is minus 3x, and minus 5 times 2 is minus 10. So we present the quadratic as shown. X minus 5 is a factor which is common to the first two terms and the last two terms. So we can factorize as shown. And as you can see, the two lines are equivalent. X minus 5 has been taken out as a common factor, and x plus 2 is the other factor. And so we have factorized our quadratic. And now for exercise 2c, factorize the expression shown. And so our quadratic has been factorized. And now for exercise 2d, factorize x squared minus 16. This can be expressed as x squared minus 4 squared, or the difference of two squares. And so using the formula for difference of two squares, we can express this as x minus 4 times x plus 4, as shown. Now for exercise 3a, sketch the graph of y equals 5x plus 2. Clearly the line y equals 5x plus 2 is linear. So we find any 2 points on the graph and join them. The easiest 2 points to find are usually when x is 0, what's y, and when y is 0, what's x. So let's find out what's y when x is 0. We plug in the values in our line, as shown. To give us y equals 2. So when x is 0, y is 2. That's 1 point on our graph. And when y is 0, let's plug in our values. and rearrange. And finally, dividing by 5 gives us x equals minus 2 over 5. So the 2 points on the line are 0, 2 and minus 2/5, 0. We can plot these on our graph. 0, 2 is as shown, and minus 2/5, 0 is as shown. We simply join the points and we have our line. Now for exercise 3b, sketch the graph of y equals 3 minus 2x. Y equals 3 minus 2x is linear. So find any 2 points in the graph and join them. The points we're considering again are when x is 0, what is y, and when y is 0, what is x. So let's consider x equals 0 first. So when x equals 0, plug in the values and tidy up to give y equals 3. So one of our points is 0, 3. Now when y is 0, plug in the values again, as shown. Then rearrange to give 2x equals 3. And finally divide by 2 to give x equals 3 over 2. So the 2 points on the line are 0, 3 and 3 over 2, 0. As you can see, we've plotted both of these on our graph. We simply join the points and we have our line. And now for exercise 3c, sketch the graph of x plus 3y equals 18. Again, x plus 3y is 18 is linear. We find any 2 points in the graph and join them to sketch our graph. When x equals 0, plug in the values in the equation. Rearrange to give 3y equals 18. And then divide by 3. Giving y equals 6. And now find the other point. When y is 0, again, plug in the values in the equation. And tidy up to give x equals 18. So the 2 points on our line are 0, 6 and 18, 0. Let's plot these points. 0, 6 goes here and 18, 0 goes here. We join the points and we have our line. Now for exercise 3d, sketch the graph of y equals 4x squared. This is a quadratic expression. But before we tackle this, let's look at some background. Consider a quadratic of the form y equals ax squared plus bx plus c, where a, b and c are real and a does not equal 0. When a is greater than 0, we have a minimum turning point, as shown. And the turning point occurs at minus b over 2a. When a is less than 0, we have a maximum turning point, as shown. And this also occurs at minus b over 2a. Besides the turning points, the other points on the graph which are very important are the roots. These occur where the curve crosses the x-axis. Now the roots of the equation ax squared plus bx plus c equals 0 are found by using the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. When b squared minus 4ac is greater than 0, we have two real roots. When b squared minus 4ac equals 0, we have one repeated root. And when b squared minus 4ac is less than 0, we have no real roots. Now when a is less than 0, the scenario is similar. However, the curve is the other way round. So again, when b squared minus 4ac is greater than 0, we have two real roots. b squared minus 4ac equals 0, we have one repeated root. And when b squared minus 4ac is less than 0, we have no roots. In order to plot our quadratic equation, we need 3 or 4 key points. We need the x-intercepts and the y-intercept, i.e. when x is 0, what is y? And we need the axis of symmetry. So let's go back to our quadratic, y equals 4x squared, and sketch it. Now since a equals 4 is greater than 0, the graph has a minimum turning point. Also, 4x squared equals 0 has a repeated root at x equals 0. And finally, since y equals 4x squared is greater than or equal to 0, the graph will look something like the one you can see on your screen. Now let's take a look at exercise 3e. Again, we're required to sketch a curve. The equation y equals 2x squared minus 8x minus 5 is a quadratic again. Now since a is equal to 2 and greater than 0, the graph has a minimum turning point. Now to find the roots of where the graph crosses the y-axis, we let this equation equal 0 and then use the quadratic formula. The b fits in here. A times c goes here as shown, and a goes here. And then we tidy up to give two values of x. Plugging this into our calculator gives x equals minus 0.55 and x equals 4.55. So now we have the roots of our equation. And when x equals 0, y equals minus 5. We can find this value of y by simply plugging x equals 0 into our original equation. Now, since the turning point occurs at minus b over 2a, we have that the turning point occurs at minus 8 over 4, which is of course equal to 2. When x equals 2, we plug the x equals 2 into the original equation to give y equals 8 minus 16 minus 5, which is of course equal to minus 13. So when x equals 2, y equals minus 13. And so we can plot our graph. Since a equals 2 is greater than 0, the graph has a minimum turning point. The roots of the equation are at minus 0.550 and 4.550. The y-intercept, i.e. when x equals 0, y equals minus 5. And finally the turning point at 2 minus 13. And so we have our graph. Let's now solve review exercise 4a. We are required to solve and sketch x plus 8 less than 10. We subtract 8 from both sides of the inequality. as shown. Tidying up gives us that x is less than 2. Now, since this is a strict inequality, we draw the line x equals 2 as a dotted line, as shown. The region x less than 2 is to the left of this line. Now for exercise 4b, we are required to solve and sketch 2x minus 7 is greater than or equal to 17. Adding 7 to both sides gives us the equation shown. And tidying up gives us that 2x is greater than or equal to 24. And therefore x is greater than or equal to 12. As you can see, we've simply divided by 2 to obtain this. As this is an inequality and not a strict inequality, we draw the line x equals 12 as a solid line. And the region 2x minus 7 greater than or equal to 17, or equivalently x is greater than or equal to 12, is the shaded region to the right of and including the line at x equals 12. Now let's solve exercise 4c. We are required to solve and sketch 5x plus 3 is less than or equal to 2 times 2x plus 2. Let's expand the brackets on the right-hand side to give 4x plus 4. If we subtract 4x from both sides, as shown, then tidying up gives us 5x minus 4x is x, the 3 stays as it is, 4x minus 4x cancels, and 4 stays as it is. Now we can put the constants on one side and the x's on the other. So we subtract by minus 3, which gives us x is less than or equal to 1. Again, as this is an inequality and not a strict inequality, we draw the line x equals 1 as a solid line. And the region x less than or equal to 1 is the region to the left of this line and including the line x equals 1. Now for exercise 4d. We are required to solve and sketch 7 minus x is less than 13. We're going to add x to both sides in order to make the x positive. As shown, which gives us 7 is less than 13 plus x. And then subtracting 13 from both sides in order to have the x's on one side and the constants on the other, gives us minus 6 is less than x once we've tidied up. So 7 minus 13 gives us the minus 6. The 13's cancel, and we're left with just the x. Now, as this is a strict inequality, we draw the line x equals minus 6 as a dotted line. So the region x greater than minus 6 is to the right of this line. This brings us to the end of this session. If you have understood its contents, you should be able to solve linear and quadratic equations, factorize equations, and sketch graphs of equalities and inequalities and label important points on the graph. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to it.